Good morning, everyone. Today I'm going to show you. Yesterday also I tried during the first video conference time to show you a series of video regarding 5E learning. But today here I'm recording and going to upload it on YouTube. And the video I'm going to share you is copyright to Science by Doing, engaging students with science, which is specially designed and produced by Australian Academy of Science Teaching, and one of the great team working around the world, contributed to many science learning process and many others videographs, and as e-learning they publish with ISBN number. So I don't own this particular video which I'm going to share in between, but I may be orienting about this videograph. So first, let us start with some video. Let us begin with the video graph, which it explains about 5E cooperative learning, notebooking. So here we will only use the 5E one, and many others models are there which we can use in the for constructivist learning approach, classroom design. So just let's start with this. So that you can try to understand and contextualize many subjects. Here one example on a particular topic of school level will be demonstrated, which you can contextualize later on. Let's begin with this.
Hi, the purpose of this resource is to provide some practical advice on how to enhance student learning. We're going to look at three aspects: learning theories, cooperative learning, and notebooking. There is a second chapter on the DVD about notebooking that you might like to show your students. Our ideas of how students learn affect the way we teach. The 5E model is a simple model. The teacher describe how she has used the model with her Year 9 class.
What we're going to be doing today is we're going to be doing two activities to start you off thinking about plate tectonics and to help me understand what it is you already know about it.
In this unit, I was doing plate tectonics. We've been doing geology already this term, and one of the things that's difficult about teaching geology is students always want to know, why do I care about rocks? And it can be very difficult to do that without taking them out of the classroom, but excursions can be difficult to organise, and so I wanted to find a way to make plate tectonics relevant to my Year 9 students.
Around the benches I've got a whole bunch of articles and pictures from some of the recent extreme geological events.
What I hoped to do was to use some of the recent media about geological events to help them actually think about why it's good to know about plate tectonics.
There was a big volcano in Iceland and all flights across Europe had to be cancelled.
Hoping to get them to see that yes, it is relevant and it is important to know these things.
What I want you to do with these is in groups is to have a look at the resources there, have a read of the articles, have a look at the pictures, and talk about and think about, first of all, what the human impact of these events have been, okay? But also then think about, so what actually caused these events? What's going on that made these earthquakes and this volcano happen? And this is so that I can see what you already know, what ideas you already have.
As well as making it relevant to them, I also wanted to know how much they already knew. Their teacher from the previous year had told me they'd spent some time learning about plate tectonics. I didn't want to go over things they already knew. So in this stage, I was looking to find out what had they remembered from last year.
So can I get you in groups of 3 to 4, just sitting at the benches with your books so that you can have a look at these things? If you had any thoughts about how these things happen?
Well, which one?
Any of them, pick one, doesn't matter.
Well, we think this one because of all the gases that are built up over heaps of years, and it's just made it so powerful. Plus, because it's in the snow and just what is that?
This is a freeway. It's like a raised freeway. So that would have been a road above another road. what do you think might have caused this earthquake? Do you remember anything from year 8?
Fault line or something.
Fault line? Yeah. Do you know anything about where Japan is that makes it particularly prone to earthquakes?
The Ring of Fire.
Do you remember what the Ring of Fire is?
It's where active volcanoes are.
So what do you guys reckon? What kind of effect do you think these events had on the people who lived through them? For each group, I want you to put just a thin layer of jelly in the bottom of the tray, so it only needs to be 1 or maybe 2 centimetres deep.
The explore phase works best, I find, if it's fun for the kids, something hands-on that they can do and play with, and the jelly was nice and messy, which they enjoyed.
We're going to use some slabs of plasticine and put them in our tray on top of the jelly, and we're going to move them around. Okay? I want you to move them together, I want you to move them apart, I want you to try sliding them past each other, and I want you to observe and record your observations about what happens to the slabs of plasticine, what happens to the jelly.
What I was trying to achieve with it was firstly to help them consolidate what they'd already shown me that they knew in the previous lesson, and also to then have something that they can hang their new knowledge on once we go into the explain stage.
The bit that I want you to be focusing on is what's happening where the edges meet, so whether they're coming together or going apart or sliding past each other, what's happening at that point. So if the jelly's coming up over the outside, that's okay. Do you have space to slide them past each other this way?
A little bit, yeah.
In this explore stage, I asked the students lots of questions. I wanted to help draw out their knowledge of what they'd shown me in the engage stage and help give them something to hang it on. I didn't want to tell them all of the answers. I wanted them to be able to explain things in their own language. It didn't matter that they couldn't remember the scientific terms because we were going to learn that later. So long as they could talk about things in a meaningful way, even if they weren't using the proper words for it, that was enough.
Do you think this is modelling? What idea do you think I'm trying to model here with this little
tectonic plates?
Okay, so what causes these plates to move? The magma heat. What does the heat do to the magma?
Makes it liquidy.
Yeah, circulating. Do you remember what that circulation of fluid is called? 2 words start with C. It's a method of heat transfer. If you don't, that's okay. But so that circling heat is a really good idea that you should note down. Well, let's have a think about the beaker and the polystyrene. What are some observations that people made?
Moved around.
It moved around.
Because of the heat?
Because of the heat.
The jelly and plasticine model didn't work quite the way that I wanted it to. It was a bit difficult for the kids to grasp it because the jelly went all over the plasticine and it didn't really model very well the magma coming up between the plates. So in the future I'd probably use different materials, things that might be a bit more flexible than the plasticine to show how the plates deform when they come together. What I was really happy with though was the convection current model with the styrofoam in the boiling water. They quite easily saw that the boiling water represented the magma, and though they couldn't always remember the scientific words, again they knew what was happening that was causing the plates to move in that instance. By this stage in the unit, the kids were asking a lot of questions, and rather than giving them the answers straight up, I wanted them to have an opportunity to find out the answers themselves. But I wanted to do that in a guided way. So I took them to the computer labs, gave them some websites that I knew had good information on them, and gave them some questions to guide their research so that they could find the answers themselves. I also wanted to make sure that they were linking what they were learning now back to what they'd done in the previous lessons with the models that we did, and also the engage stage that we did, linking it back to what was happening in the real world.
It moves apart and then magma comes up and creates new rock, making the mid-Atlantic ridges. And then so all the older rock gets spread out further away.
So what's the scientific word for moving apart?
Divergent.
Yeah, so when they're diverging, yeah, okay. What's happening to Iceland as these plates diverge?
It's getting spread out.
Well, is it getting split in half though?
Or just get bigger.
Yeah, it's getting bigger.
Yeah,
Because every time it moves apart, more rock, magma comes up and forms more rock, and it just keeps on getting wider and wider. Last lesson in the computer lab, we looked at convergent, divergent and transform boundaries. This second part of the explanation phase, I used a much more traditional chalk and talk kind of method because in the computer lab they'd had the opportunity to work at their own pace and sort of guide their own learning, but I needed to make sure that they knew what I wanted them to know. And the way I chose to do that was to come back to the classroom with a much more teacher-focused lesson where I was making sure they did know what I wanted them to know, but also asking them lots of questions to help draw out what they'd learnt from the computer labs, just to make sure everybody was on the same page. Jerry, can you answer the first question?
Atlantic Rift.
What's happening there? You use the word rift. What do you mean by rift?
Well, there's the lava coming up and it fills the crusting on the top.
Yep. What makes the lava come up?
Plates are moving apart.
Ah, excellent. So why do we get earthquakes at these locations?
Rocks aren't smooth and they're like rough on the side, so that when they rub together it causes friction, which and then they kind of stop, and then in this sudden movement they just go bang. Fantastic. It stores energy and then releases it all of a sudden, which causes earthquake.
With this elaborate stage, I was looking at trying to extend their knowledge. Hopefully, by the end of the explain phase, they had a pretty good understanding of basically what's happening in plate tectonics. But to really help cement that, I wanted to give them something tricky, something difficult, to make sure that they understood the first stuff, I suppose. I'm going to show you a video just for a couple of minutes. This is about Hawaii. Okay, and then I'm going to ask you some questions about Hawaii.
Kilauea spews forth molten rock in a daily spectacle of creation. The landscape of Kilauea may seem alien and forbidding, but some find it irresistible.
I'm going to give out maps of the chain of Hawaiian islands. The example of Hawaii is a good one because everything we'd done up to that stage had been about what's happening on the plate boundaries, on the edges of plates. But Hawaii is a volcano in the middle of a plate. And so getting them to think about what's happening there helped solidify their understanding of what was happening on the edges and why it's different if it's in the middle of a plate. Does anybody have any ideas that they would be willing to share?
In collision zones, right, mountains rise up from on the edge, but maybe there's two plates crushing it from both sides, causing mountains to come up from the middle of the plate, making volcanoes in the middle.
Is it possible for to be a magma pool underwater and then it keeps on building up and then it crystallizes back into rock and then it keeps on going until it's big enough to reach above the water?
Has anybody heard of hotspots?
Something to do with volcanoes.
They have island arcs which form because there'll be a volcano which builds up and then it moves along and there's another one and then you have this island arc.
This lesson ended up being trickier than I thought it was going to be. I was surprised at how much trouble the students had grasping the concept of the plate moving above the hotspot. And in the end, we just had to get out the Bunsen burners and the gauze mats and get them to do it themselves. And then finally, I felt pretty confident that they'd got it. I think them doing it really helped. Me standing out the front waving bits of paper around, I think a lot of them it didn't make any sense at all. But once they could do it themselves, that hands-on experience again really helped them solidify their understanding. Think about which direction he's moving the gauze mat. This final part was rounding off what we'd done with an evaluation to show both me how much the kids had understood, but also to let the kids know where they were at, whether they'd understood what I wanted them to understand. The question itself can be as complicated as you like about plate tectonics, so long as the answer will be no more than a simple short sentence or a simple diagram.
I used a technique that I've used before, and it's a bit fun, and it's a good way for the kids to see what they know. I got the students to write their own questions for this little quiz, and they came up with some really good questions and some really curly, tricky ones as well, which I was particularly impressed about.
Round 1, question 1. When two continental plates collide, what does this form?
See, I told you.
And so in groups they were answering the questions that they and their classmates had written themselves.
2. What is a transform boundary?
No, you're right. I'm not very fast. Try it one where they slide past each other.
Question 3. With all the different ridges, boundaries, subduction zones and collisions along each tectonic plate, how does each plate crust keep the same relative area all the time?
What it showed me was that basically they did understand things quite well, and it showed them that. So they were all on about the same page, they all knew pretty much what I wanted them to know, and they'd shown that to themselves as well as to me.
Form.
When oceanic plates move apart.
Okay, so that's all 5 questions for the first round.
The thing I really like about the 5E model is that it gives me a structure in which to plan my lessons and units. It reminds me to do hands-on practical lessons with the students. It encourages me to do student-directed learning like I did in the computer labs. And it gives me lots of ways of both me and the students finding out what they've learned.
It should be emphasised that the 5E model does not control your teaching. You control your teaching, but it does provide some very good guidelines based on sound research. Another dimension of student learning.
So dear friends, it was little bit of demonstration. I hope you can catch it here up with the demonstration. One thing I want to reflect is that in between the demonstration, the class teacher used to express her experience and how she was thought of to engage, to proceed with the process of 5E. Meanwhile, while doing the 5E adaptation, she also mentioned about that she might have done a better alternative experiment to understand the concept. This part of sharing the experience will go to reflective diary. In our case, in reflective diary, you are going to write like this: what you thought of, how you plan it, and how after implementing your plan, how that what type of reflection you received after the classroom experience. By doing that, a self-suggestion, a self-feedback, a self-analysis can come up, which will be quite helpful to the next engagement of your class. This is how the outcome can be realized by following the principles of assessment 2, where every individual think of their own as improvement, self-appraisal, reflection, self-guidance. Lots of these things happen during this program. So I hope that you will be able to grab some of the idea from here, and you can come up with new idea and more creative kind of taking class with help of 5E model. Many other model we will discuss later on. For now, I think with this you try it out along with the framework given in your video conference classes, and share your file too to understand that. Thank you.